So it's a short lightning talk about how to build decentralized productivity app on IPC. So why do we need it? So it's a very simple argument, right? Like the argument similar to argument of any decentralized system. You want to have independence from centralized infrastructure provider, and it would be really cool to have independence from unfriendly app developers. So think about Google Docs. Like when you use Google Docs, you fully depend on Google, right? Google can do whatever they want with your data. They have some legal framework around it, but like there's a technical possibility to do with data whatever they please. But also they can change application in any direction you want. So as a user, like I want some alternative, and I want Google Docs alternatives that I trust, that have a sensible handling of my data, and I want to influence to the product direction. And actually, many of ideas that I included in this talk, I got from my previous job at Internet Computer, and I have my friend from Internet Computer sitting in this audience, who are very excited to see. Anyways, so the idea here that we will put the whole productivity application on the blockchain. So how are we going to do it? So we will use IPC, obviously, and we will use Filecoin as a mainnet and Mycelium as a L2. And we use L2 because it's just faster and cheaper for use cases that requires a lot of transactions. And use case for productivity, when you don't move money from one person to another, but you just post some requests and post some kind of data changes for your productivity application, it will be high TPS use case. So that's why we want to make our infrastructure as cheap as possible. That's why we're using IPC and all related features. So I'm not going to talk about DAO right away, but let's talk how documents work. So we will create specific application subnet to store our documents. So imagine we're building something like Google Docs, right? It's a document that have text and graphics and images, and multiple users can edit this document like simultaneously. So we will create application subnet because we want to have a plenty of storage. We want to store the data on chain. And the very simple approximation of the data structure, it will be some form of table of these documents. When you have ID, you have access control list, so all the wallet addresses that can modify this document, and you have content. And content needs to be encrypted, right? Because like you don't want anybody through Block Explorer to go and look through your documents. So let's say content encrypted, and we'll talk a little bit about how this encryption can be implemented. So then, and this is where the cool stuff starts, right? Application subnet is not that unique. But what we are thinking about in IPC team is like ephemeral subnet. And ephemeral subnet is a subnet that can be created on demand. And very often, this subnet will be created between clients themselves. So the idea, you have multiple users who have their computers, and subnet is running inside their web browsers, right? So like when you start editing session, let's say multiple clients, let's say 3 clients want to start editing session. So the client stack inside of your web browser will work as a validator, and they all share the data around some form of consensus algorithm. So, okay, so when I want to open my document, I automatically create this ephemeral editing subnet, and we will have a smart contract that's called editing session. So when each user wants to make a change in the document, they call somehow the method of the smart contract, and I will explain how a little bit later. And this change gets through the consensus algorithm. That's how we get multiplayer essentially for free. And once the change is committed as a part of the state, this document can be encrypted and sent up to the application subnet for long-term storage. So in this way, if this ephemeral subnet get disconnected and stop existing at some point, then you still save work in progress by submitting your checkpointed the data up to the parent subnet. So far, so good. So the question is like, there is 2 interesting parts of this. Like, how does the client work, and how do we prevent, like, let's say, unfriendly developer from moving this application to the directions you don't want? So let's talk about the client. So the client will have 2 parts, essentially. You have a validator, the code that runs this ephemeral subnet, And you have a front-end app. Is the app that renders the elements of the user interface, that interacts with the validator, submit data, and so on. So we need to load it from somewhere. And the idea here, since we are part of a Filecoin ecosystem, we can put this data on chain because it's a static assets that need to be loaded by your web browser. It's not like a server rendered web page or of sorts. So you can just load it from some static provider. So we can utilize Saturn CDN and fetch this data directly from Filecoin network. So the data will be stored on some form of Filecoin service provider. You can fetch it through Saturn CDN through HTTP and load it inside of your like web browser on your computer. It is an interesting question how we can do it on mobile. It's probably requires more exploration, but there are some ideas. So in this way, you can have this completely decentralized client and completely decentralized system for managing your documents. And it's all possible because we're moving this logic on chain, right? There is no like external databases, there is no AWS, there is nothing, it's just only blockchain and CDN provider. Okay, so how do we protect against unfriendly developer? And it's an interesting question. So we can create a DAO. And DAO will be situated on Mycelium because you need to be like the DAO logic, the smart contract itself, and the user kind of stakes inside this DAO needs to be registered on some subnets that we trust. And we probably trust Mycelium more than some application level subnet. Okay, so when we need to deploy a change into this application, so we can create some kind of pull request or deployment module, whatever, something stored on Git or some other version control system. So something that is built, and when we want to deploy, we can use a liquid democracy process through the DAO to vote which code should be deployed and which code shouldn't. So essentially, when a developer make a change into the code, this change can be incorporated in some form of application binary. It can be deployed. It can be sent to DAO for voting. And if voting is successful and deployment should go through, the deployment is proceeded inside application subnet, and we can change the smart contracts and can change all other code. And the same process can be applied to the static assets that is stored as part of Filecoin service. That's pretty much it. So this is a sketch, and essentially back of the napkin idea how we can utilize IPC to make application like a larger part of application on chain and make it fully decentralized. Thank you.